And this is going, that's good. Okay, so we're off. Let's do this. All right, so tonight, as I get started, our main goal is graphing sine and cosine graphs.
Easy.
Easy?
Easy.
Why is it easy?
Because I did this last semester.
Good for you.
There's some Calvin.
Is today the 25th? Yeah, I guess it is, right? I'm just checking one more thing before we officially get started here. Definitely got to grab attendance today. We're a little bit short on peeps. All right, so Roman said graphing trig functions is easy.
So once you know how to do it.
Yeah, once you know how to do anything, it's easy, right? Sorry, one second. There you go. Well, I hope it maintains its ease for everybody. And if you know how to do it, then just bring it back to life. All right, officially off. Good question. It is a little odd. Okay. That's interesting. All right, so what do we remember? We're going to kind of activate any prior knowledge, as we call it in the education world. And Roman says it's easy. I've never had that as the first thing on my list, but
I'm
confident.
It has a max and a min of -1 and 1.
Max, min values are important. -1, 1. So by the way, those are our outputs. And if our outputs cannot go less than -1 or greater than +1, this sounds like range. All right, just kind of getting this going. We'll clean this all up. This is just what I call in the high school classroom a whiteboard splash. We spit out what we know. There's no wrong answer. There's no right answer. There's just whatever comes to mind when you remember trig functions, getting us to think about it. What else?
Transformation equation.
Transformation equation. So we can transform them. Yeah, because I was going to kind of push back on this for a minute. If we transform something, we can stretch it and shrink it, so we can definitely change that range. So something has a range of -1 and 1, but not every single trig function does. Waves. That's a good one. What else?
Cosine always starts at a max or the min, and sine always starts at the middle.
Starts at max or min. Sine will start at its mid. Oh, cool. Actually, very good. That's going to get some asterisks because that's important. Period of 2 pi. You guys know a lot of this. Cool. Who knows none of this? If you have not had trig in a long time, this would be really.
That makes a lot more sense when you know the unit circle.
Does it?
Yeah, the 2 pi and the -1.
So this connects to the unit circle?
Yeah, coterminal angles. It really helps understand. understand everything a lot better instead of memorizing.
So how does the graph connect to the unit circle? Let's talk about a sine graph.
Well, because 2 pi is a full period and 2 pi is equal to 360 degrees, which is a circle.
So as we rotate angles, and let's keep it simple, degrees. So if I start at 0 degrees, which is right here, and I rotate to 90 degrees, what happened to the y coordinates on the arc length? Did they stay 0? Because they started at 0. So right there, we know it starts at 0. So the graph moving up, it's increasing. It's going up. So we get a wave that is increasing to a maximum height of what's the y coordinate right here? 1. And so whoever said you have a maximum of 1, that's why. This is the maximum height. Kind of like a Ferris wheel question from last class, which we'll kind of cycle, no pun intended there, but cycle that back in at some point tonight. So we have this maximum height. And now the Ferris wheel car starts coming down until we're at a height basically of 0 again. And that happens at what angle of rotation? 180 degrees. So you kind of have this symmetrical behavior. And we can start to see a wave emerge. Well, it's called a wave whether you see a wave. Maybe some people say I see a half circle or an upside down parabola or whatnot. But anyways, as we now are rotating from 180 to 270 degrees, we continually decrease, and these y coordinates are less than 0. They're negative, so the graph goes below the x-axis until it gets to its minimum value of -1. And then we continue rotating around one full circle to 360. But talking about the Ferris wheel cars maybe as an analogy, we're starting to go back up. So all the way here, the graph is going down. But then it, at 270, starts to go back up.
And most importantly, when we're talking about cosine sine graphs, we also refer to them as radians instead of degree symbols.
So we can do radians, we can do degrees.
Usually
It's usually radians, right? But I'm just going with degrees because that's our most comfortable. But pretty soon we're just going to use radians. And as I said before, calculus only uses radians. So cool. So if you never thought about it that way, when there's a connection to the unit circle, yeah, it's literally just kind of thinking about the y coordinates. We're starting at 0 rotations. As we go up to 90, we're going up. From 90 to 180, they're decreasing. Actually, they're decreasing all the way to 270, but 180 is kind of like a landmark, a key value to keep in mind, because it's an intercept on the graph. It's a 0. You hit its minimum value at 270 degrees, and then we start increasing. The graph is going back up at 360. And actually, if you've been a long time or if you've never seen it, which I'd be surprised, but if you've never seen that, there is what we call y, the outputs of sine x. At least one period of it. Because what David mentioned is that we can continually go around this circle. So we could go beyond 360. But what happens is, well, it repeats itself. So whatever height you were previously, it's just going to repeat itself onwards and onwards and onwards. And can we think about negative angles? Heck yeah, right? We already defined negative angles. As a reminder, it's just our rotating in this direction, clockwise direction. So we could actually just kind of imagine this is one fundamental cycle of what a sine wave does. After this, it repeats itself, and that's what we call a period. Just a fancy word for how long does it take to start repeating itself. And the connection to the unit circle one last time, the fact that the time it takes to repeat itself is 2 pi is kind of, to me, obvious. I don't know how else to say it, but it's just because you're going around a circle and you're eventually just going to repeat those y coordinates.
On the exam, are going to throw that we have to solve the whole unit circle for one of the problems, or probably not?
I wasn't going to, but now that you ask, sure. Okay. Anything else someone wants to add? I think we got our brains working. I would be able to complete it in a circle, for sure. No. All right. So more formally, if you kind of were just sitting back, or I said don't take any notes, graphs of sine and cosine are called sinusoidal. If you don't remember what the cosine graph is, we'll build it in a minute. But when you see this word sinusoidal, it really refers to either a graph of a sine or a cosine. Even though the word sounds like sine, a cosine graph is also sinusoidal. And that's because what we just explored there, a little more carefully now, but in radians, oops, I want to do this. This is a sine wave that if we rotate 0 radians to pi over 2, increases from 0, the graph is increasing till it reaches its maximum height of 1 at pi over 2. Then it starts to decrease at pi, a half circle, 180 degrees, but we're going to do radians. You have an intercept again. Still continuing to decrease till we get to our minimum value right here of -1. And all these are the y coordinates on the unit circle. And that happens at 3 pi over 2 until you increase to 2 pi. And from there on, it just repeats itself. So maximum value of 1, minimum value of -1. This is called 1 period. And I probably should name this function as y equals sine x. Okay. What else do I want to talk about here? We talked about intercepts really quickly, the max value, the min value, the wave shape. The reason this is called 1 period, more formally now, is if we were to extend beyond 2 pi, so 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi out of 2. So if we went to 5 pi out of 2, meaning just beyond, this would start to repeat itself. 6 pi over 2 would be 3 pi. So it would be back here. Right? It just starts repeating itself. And you can go as far forwards as you need to whatever. If it's a math class, the directions should tell you how much to graph to. But if you're actually applying it, then you know this could go on and on and on forever. And as I mentioned in kind of our warm-up, not just rotating counterclockwise, that's what all these are, positive angles of rotation are counterclockwise. We could rotate counterclockwise, so negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. But ultimately, negative 2 pi just means like we're coterminal with what we started. And then as you go around, well, I'll let you think about it, but it actually just makes this wave again. I want to try to keep it as neat as possible here. And so on and so on and so on. And so now we can see the sine wave more in its entirety. But I really want to stress on where we started here. 1 period is really all we need. From there, we can just use repeated reasoning to sketch or think about as much as we need to. Okay. I think I want to add one more important detail here. 1 period is 2 pi. Might be a little more important later, not right now, but one thing I commonly refer to this is, actually it's not what I refer to it as, it's what science referred to it as the crest. And this part right here, do I have a gray? Do I have a gray? Yes, I do. What do we call that? Trough. Yes.
I was honestly going to say Poisson. I know.
So that's not super common. I get that, but you'll see why. Students who take my course will say, "Oh, that was helpful." And actually, it was students who taught me to use those words that made a lot of things more helpful. Coming up, so this is just like, this is facts. We haven't done anything yet. All right.
Oh, and something that might matter to somebody going into electrical engineering is that the period over seconds is hertz.
Period over seconds is hertz. So there's an application that I did not know, but now I just learned something. Period over seconds is what a hertz is. So whenever I see that hertz car commercial, no, I'm just kidding, but I get it, like the electrical thing. Interesting. One teacher I work with at Cranston West is in the engineering, and it's general engineering, so it's all different types. But some of the applications she was showing me, I didn't necessarily understand the vocab or like the actual application, but some of the waves that were coming up, well, all the waves were sine waves and things like that, even just interesting. So I, at some point, want to learn more about how this is applied, but I also want to do a lot of other things. So add that to the bucket list. All right, graphs of sinusoid, or graphs of sine and cosine are called sinusoidal. This right here, by the way, is going to be our parent graph of sine. David also mentioned that we're going to transform this. Yes, that's coming up very, very soon, like maybe 10 minutes or less. But these are the key features for the sine graph. And I think it was, why am I blanking on your name? I want to call you Orlando, but it's not. Gennaro. Well, I said that last night. All right, I was getting there. Orlando is right there. Well, okay, so you had mentioned that a sine wave starts at its midline. So here's an important point too. So if we think about like max and min, well, we don't have to think about it, it's right there. And then you say meet me in the middle. And we think about start, like no rotation is really our starting point. It starts in the middle and then goes up to its max, down to its min. We'll build on that in a minute. But I do want to emphasize that this is starting at its middle, in between the max and min. All right, I think we've exhausted everything there. Let's look at cosine. Very similarly. All right, let's refer back to a unit circle for a minute, maybe right over here. This is the point 1, 0. This is the point 0, 1. That right there is negative 1, 0. And this right here is 0, negative 1. But if we're graphing cosine, I'm really just concerned with the x coordinates. And so, all right, let's do no rotation. What's the x coordinate there? 1. So 0 radians. Outputs 1. We haven't rotated anything. There's 1 point on our graph. And similar to like right up here, if we rotate to pi over 2, kind of want to match it up with what's right above there, even though not identical. We now have an x value of 0. So we have an intercept. And then matching this, that's about where pi is. Rotate to pi, our x coordinate is negative 1, and so I can make less steps. I'm just going to jump to it. At 3 pi over 2, we're back at an intercept, and then we're back at our maximum. They're not easy to draw. They're not impossible to draw, but it's a decent enough sketch. And for our reference, this is 1 period, again, from here to here. This is what we call a period, which is 2 pi of a cosine cycle. So first of all, they both have the same period of 2 pi. Makes sense. As you go around a circle, this is just going to repeat itself over and over again. It also has a minimum value of -1, a maximum value of 1, and notice we are starting at a maximum. So when we say start, we're really talking about the y-intercept. We're really kind of saying the y-intercept is our start. Being slightly informal. And why is this still considered a sinusoid? Well, if I just copy this over here pretty quickly without filling in all the number values. And if you want more, there's plenty of stuff online, plenty of stuff in office hours. We can build this. But this is a pre-calc class, so it's kind of like the main ideas of trig. If you want more, and if you haven't had trig, take a trig course, even if you've already had pre-cal. You take a little more care here. But these are really the main ideas. Basically, we could almost say, like, if I stripped the axes, like I didn't put the axes, and all we had was this wave, you wouldn't be able to tell, am I looking at a cosine graph or a sine graph? If I didn't tell you anything about starts or number values, you would literally just see waves, right? That's my idea here. I don't want to mess it up, but I'll say it one more time. If I erase the axes on both of these and didn't say any more, you would say, I see maximum of 1, minimum of -1, repeats 2 pi. Technically, there's a crest and a trough. And if you didn't know the number values, you wouldn't be able to tell them apart. So for the last time, that's why both of those graphs are called sinusoidal. They model things that, actually so many things, not just the application David said. That kind of application of a Ferris wheel. So models height on a Ferris wheel. Woo, yay. But some interesting things like tides. So we have high tide, we have low tide. We'll have high tide again, we'll have low tide again, and so on and so on. Temperatures, high temperature, low temp, high temp. All right, so it's not perfect because temperatures do change over the seasons, but they do serve a purpose. Sale of winter coats. December, July. December, July. Right, so things like that that in the real world kind of repeat themselves, and there's a maximum and a minimum. Sinusoids do a great job at starting to try to model them. All right. One question in the homework, or at least one question, as we go through tonight, we'll talk about the 5 key points. So I'm not going to go crazy with it. It's more just so you're not caught off guard. The 5 key points. I like to say the 5 landmarks. Are 0, pi over 2, over there at pi, down there at 3 pi over 2, and back to 2 pi. These are really what we're going to focus on over even when we start transforming very, very shortly. But these are your angles of rotation. And remember that sine, like the sun, starts kind of at 0 on the horizon, reaches its maximum at noontime, is underneath us while we're sleeping, and then rises again on the horizon. That's how I think about it. 0, 1, 0. So it starts in the middle, hits its max, min, that's it. Where cosine starts at its max, not because, like, it's literally, that's 1, goes to 0, -1, 0, 1. Some students just memorize this table. I don't think it's helpful, but I'm not those students. I just memorize the unit circle landmark values and Just get better at it that way, okay? But if the text or when the homework asks you, think about the 5 landmarks, it's just saying, think about these rotations. Anything else? Yes. So far, so good? Kind of all remember this? What's the vocab associated? So let's get into the transformations. I'm going to use capital letters. While this may seem very, 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 very new, it's really not. Unit 1 spent at least one full lesson really digesting in group work, transformations. And so here's my connection. Oops. We had 4 transformations earlier in this course. There's still 4 transformations here. All of a sudden, this just turns capital A, but it's still, at the end of the day, mathematically, it doesn't care if we use lowercase a, capital A, or some Asian symbol. It doesn't matter. You're multiplying a function. You are vertically stretching it or shrinking it. I'm going to jump to the other extreme here. If you add to a function, whether you call it the letter K, capital D, or some alien symbol, doesn't matter. When you add to a function mathematically, it's going to shift it up and down. Inside, and this is going to play a role. It is super common in trig world for the inside not to be factored. That's important because in factored form, H is your horizontal shift. But that's not factored. So we're going to be a little careful here. I'm not going to say this is the shift. It's going to play a role in the shift, but it's not the shift. But B is going to be the same thing because actually we're just going to do one thing once we see it. We're going to factor, and that we're going to factor this number out. So that's going to stay the same. And B is going to be our horizontal compression or stretch. And remember, if we see a 2, it's actually a shrink by a half. Whoa. We'll put this all together, okay? So, more formally now. Yes, this is a vertical stretch, but it gets a fancy word called the amplitude. Amplitude is the absolute value of A, but it's basically your vertical stretch or shrink. We also know it can reflect the graph. D is called the midline. And all it's going to do is shift our midline up or down. A moment ago, we said the period, that magenta color I used, was 2 pi. If I horizontally shrink it, I multiplied the inside literally by like a number like 2. Because if that was 2 on the inside, remember it actually multiplies by a half. So that distance would become half. So anyways, let me just write it. That's the period. But we're shrinking it by b. So we actually don't multiply by b, we divide by b. This is multiply. We do the inside opposite. We're going to shrink that period by b, or a factor of 1 over b, I should say. So the period of a transformed trig function is 2 pi, or I should say sinusoid, is 2 pi over b. Okay, this will make more sense once we do it, once we actually put concrete numbers here. But your phase shift, as it's called, is not c. Well, let's see. If I factor out b, it's like dividing by b and dividing by b. There's your answer. Your phase shift is c over b. And those are the facts for any sinusoidal. True for cosine 2.
And another application in this form, equational form, anyone doing any kind of electrical engineering, the period would also be your frequency.
Oh yeah, so 1 over your period is your frequency. Not so, it sometimes comes up. It's not. Thanks for sharing that too. Little added knowledge. It's more science based. I've seen some textbooks have it, but yeah, it's not in our homework. Not that it's not a reason to study it, but 1 over your period is called your frequency. There you go.
And the equation for the period also explains why when it's less than 1, it actually stretches.
Yeah, does that make it makes sense? Until I didn't get it as a student when I be teaching it, and I really like sat down and learned. Oh man, I get what's going. It makes so much sense why it's 2 pi over b, not times b. And wicked counterintuitive, wicked unhuman. All right, I meant to copy. I didn't mean to waste as many papers here. It's not waste. I think it's very valuable. We're gonna really make sure we have this lesson down with less vocab. I mean, the vocab's there. The theory's there. You should have had some background. If not, we're really just gonna apply it. And I'm not going to do all the talking tonight. I want to get you guys kind of thinking independently, working together, actively learning. But we'll do some of these, all right? So a little balanced approach here. Number 1, which function listed below matches the details listed in the columns? So I'm going to work through this in my way, all right? Let's just go this way. What's the amplitude of this first f of x function? So our amplitude, to remind us, is the absolute value of 2. That's kind of silly. Our amplitude is 2. Second question. Is what's inside cosine factored? The answer is yes. How do I know that? Literally, because I know what it means to be factored. Secondly, when I look in front of x, it's inside a group. So I'm just focusing on that. And what's its coefficient? 1. That means it's factored. Right? So if you see a coefficient of x with 1, it's factored. Therefore, the period of this function is 2 pi divided by 2/3. What's the shortcut for dividing by fractions? Keep, change, flip. So I'll write it, but I'm probably going to write this once. 2 pi divided by 2/3 is the same as 2 pi times its reciprocal. Dividing by a fraction is the same as multiplying by its reciprocal. And I can see this is going to cross cancel. I'm really left with 3 pi. Because this is factored, my phase shift is 2 pi over 3 to the left. Or you could just say negative 2 pi over 3. I like the word left better, because it really is telling us shift left this number of steps, but also acceptable would be negative 2 pi over 3. Now, the definition I gave earlier was you take this value and divide it by b. Even if you did that, well, now you're becoming problematic because you'd have a wrong answer, right? If you divided by this, you would say, oh, the phase shift is negative 2 pi. So you have to recognize when you have a factored form versus something we'll see in just a second, not factored. That's the number one thing that students miss up. Number one thing. Last but not least, our midline is y equals negative 2. Okay. So I think we could now just find this information. Amplitude has to be 2. So far we got A, C, or F. We need a period of 3 pi. A, C, or F, or I'm automatically done. But let's just check the rest of our answers. Our phase shift was negative 2 pi over 3. So I would use the word left, but this, I'm not going to lie, I took this from another teacher, but I really like it. So it's all good. Negative 2 pi over 3. And then the midline, another thing I would definitely say is call this y equals negative 2. But this teacher is just saying it's vertically displaced by negative 2. But I want to focus more on the equation, okay? So we're not going to split hairs super, but I'm your professor, so follow what do I say. Okay, let's go over to g of x, and then I'm going to give you some time to kind of think about the other 4 yourself. Amplitude.
3.
Still 3. Well, let me be careful. Absolute value of 3, but it's still 3. Immediately, I recognize this is not factored on the inside, so I'm going to factor out the 2/3. And my heart starts racing. Oh my God, not what? I'm going to put it on the whiteboard, and I'll eventually put it back on the tablet. But I said something, so I'm going to do an easy example. 2x plus 6. When we factor out the 2, it's really like we're dividing by 2. Except we just leave the factor in front. So let's cut to it. If you have 2/3 x plus pi over 2, we're going to factor out the 2/3. So divide this by 2/3. Mad simple. We get our 1, which we wanted. But here's where it just means pick up your pencil, take 10 seconds. That's all it's going to take. Pi over 2 divided by 2/3. We're not going to do division by a fraction. We're going to multiply by its reciprocal, 3 over 2. And nothing cross cancels, so we're left with 3 pi over 4. And you know you can always check your work by just distributing it back through. If I distributed this 2/3 through, obviously I had to get that. And if I distributed it through here, I'd have 6 pi on top of 12. 6 on top of 12 does simplify to 1 over 2. So for a video lesson, that way when you see it back at home, if you're going to go back and watch this, pi over 2 divided by 2/3 means multiply by its reciprocal. Oops. That's not its reciprocal. This is its reciprocal. And so this just becomes 3 pi over 4. All right. Other than that, I think this is pretty much over.
And the midline is just 3.
Yep, midline is going to be y equals 3, but I'm going to go in order here. Our period is 2 pi over 2/3, but hey, we just did that about 95 seconds ago, so I'm looking over at example 1. We know that's going to make 3 pi. We're going to say that this is a phase shift of 3 pi over 4 to the left, or negative 3 pi over 4, and that your midline is y equals 3. This teacher calls it a vertical displacement by plus 3. Process of elimination, let's see. Amplitude is 3. We're at B. I feel like feel like this 3 pi over 4 is going to be a good one here. 3 pi over 4. Yeah, right there. D. G of x matches with that column there. All right, so I'm going to give you, how long do you think? 1, 2, 3, 4. 1 minute at least, plus a half. 6 minutes. I don't know. 6 minutes. If you want to do it independently, you want to turn to a neighbor, talk it out, ask for help, ask me. Now's a good time, but just want to make sure we're all leaving. And even if you can finish all 4, wonderful. If you finish 1 really well, wonderful too. Definitely try to get 1 factored and 1 not factored. I do need to run to the vending machine because my mouth is super dry, so I'll be back. All right, just kind of quickly glancing. Some of us already moved on, so I don't want to stop you, although I just want to make sure as a class we're all good. So we'll just put on this top part, finish up the one you're on, and save the rest for later, or not, right? As long as hopefully you got a couple practice in, but the majority of us are already beyond that. So if you're still finishing up the top part, finish up the one you're on in the next minute, and we'll talk about question 2. All right. How did I do? How did you do? Anyone get my answers? C, A, B, kind of up, down, and well, the left column, I should say, and then D, F, E. Yeah, cool. If you worked ahead on number 2, please share all your insights in a second. But if you haven't, what we're going to do now is just a couple of these. We're not going to do all of them. Get the vibe here. I'd like to match the lowercase function, like A, B, C, or D, with its equivalent capital function. So that's what directions say. Match F to something over here such that they're literally the same. Hint, think graphically. 2 graphs are the same if they overlap. It's not the only way to think about this, but it'll definitely strengthen your knowledge of graphs and transformations if you could say, yo, what 2 graphs are going to overlap? And we're going to learn something, if not already know something. But any ideas? Like, is there any gimmies? Are there any easy things to quickly recognize? David?
Can we look at the sheet where you showed the sine and cosine graphs?
Okay. It's a good starting point.
Sine looks like cosine just shifted to the left or right.
Right. So, actually, we're going to say, if I took where we started, and I'm going to use the word crest, that started at 0, 0. And if I shifted it to the left, right here, here's where I want to reference. If I took a crest and shifted it to the left, that would be the sine wave. But, Professor, you're on the cosine wave. Yes, but I'm saying if we shifted the sine wave to the left, or actually David's suggesting that, 100% true, we would get a crest followed by a trough. I think he's on to something. We could also say, if we took a crest and shifted it to the right and then reflected it, right? So think about that sine wave. We're shifting a crest and then reflecting it, it would become a trough. How do we shift to the left? How do we reflect? And let's go back to this question. I know the answers to those. I'm trying to be the voice in your head. How do we shift? How do we reflect? And can we start? Are there any gimmies? And then we can kind of like match maybe by process elimination. Go ahead, you.
Adding or subtracting pi over 2, it's a quarter period, and it's what differentiates cosine and sine.
So adding pi over 2 is a quarter of a rotation, a quarter of a period. Both of those are true. And this is going to shift the cosine graph to the left pi over 2.
So I think that one's A.
You think that one's A. Let's do a quick sketch. Sine, so is going to crest and trough. Cosine is going to start at its max, but we shifted it to the left, pi over 2. So a quarter of the period. So actually, those 5 key points, just shift one of them over. So instead of starting at its max on the y-axis, it's going to start its max here, go here, go, man. But you see, is this the one you're referring to? How did I do? Did I do all right or did I do terrible?
I think you did good.
Yeah, so thank you. Crash trough. And I'm thinking about it, I'm trying to share my knowledge with you. So I'm thinking about this. I want to start at its max, but we're going to bump it to the left pi over 2. Exactly what you said, though, like a quarter, one of those tick marks over. So I will say, good thinking, but it's not a match. These don't overlap. Well, we know A doesn't match with D there. You guess? I'm just teasing. I guess it goes with B. All right. So let's kind of go through that again. Sine, crest, trough. Quick sketch. This is what you need for calculus, not any glory detail graph paper and no. It's like think. That's all we're asking you to do. Think. B. So we're gonna do another sine wave. Interesting.
No, I was saying D goes with B in the other side.
This.
Yeah.
Oh, okay. You guess. Okay. Tease them. Crest trough. Reflected. That's what this means. Reflect. So, trough crest. I like those words. And, with you. We shift. We already just did this a moment ago. Shift this, start its max. Then it's going to go here, then here, then here, then here. And we have a match. Ding, 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 ding. Cool. Your knowledge of transformations and being able to look how scary that looks to the average person. Like most people are like I hate math, and it's like you're just not seeing it in a certain way. The transformation approach is a massive approach. Still takes a little time and effort. I don't know if I really want to do much more of this because I think it's such a good brain builder that I'm going to save the rest of that for you. Like literally, if you want to grow your brain, it's a perfect challenge. You do sketches. It's okay to get wrong. You say, nope, that didn't work out. We'll move on from that, right? I'll just kind of bang through some of these pretty quickly. If we have, here's like a classic type of quiz or assessment question. Just make sure you know the facts. So given a sinusoid, that means either a sine or a cosine function. I'm going to change one thing in the directions. Thank you, teacher friend, for sharing this with me, but I didn't feel like retyping everything. I will at some point. But I'd like the midline. I like calling it the midline. And then we're going to come back to this before. So if you're moving on, cool, but we're going to come back to this, and I'm going to add a part like 3B. So A is to do this stuff. And then 3B, I want to know its max and min value. And then 3C, we're going to state domain and range. So if you're feeling brave, in addition to amplitude, period, phase shift, and midline, what's the maximum value? What's the minimum value? And what's the domain and range? Here's a hint. The domain is the same for everything on this page. Won't tell you what that is yet. If you're not sure, it's all good. But that's probably the only thing that's going to stay the same on this whole page. All right, so we'll do another 5-minute independent thinking. Answer what you can. Some of part A should be really straightforward. Oof. All right, take another minute wherever you're at. I got through.
Yes, 2 more.
Take another minute wherever you're at. And then I got through this amount, and we'll kind of proceed forward from here. But if you wherever you're at, because I definitely want to talk about max, min, domain, and range too. All right, I see kind of most eyes are on the board up here anyway, so I don't want to rush us too fast, but pretty straightforward. And if you go back, definitely make sure this is recording so you can find this part in the video. Hopefully what I'm highlighting here is helpful, matching the colors. All right. It's the facts. There are transformations at the end of the day. I want to back up 1 second. We literally build a sine graph by grabbing y coordinates as we rotate around a circle. We build a cosine graph by taking the x coordinates. Looks like I have an error. All right, come back to it in a minute. Next, we can transform any function in the world from unit 1, but here they get very, when I say here, in sinusoids, they get very specific names. Amplitude, which is the absolute value of your multiplier outside. Period, well, that's going to be affected by your inside vertical stretch or shrink. Shift horizontally, shift up and down, but we call that a phase shift and midline respectively. So absolute value of 1/3 stays 1/3. That's called its amplitude. Inside the b value, the multiplier is 2. Whether it's factored or not isn't going to make a difference. 2 pi over that, it shrinks it by a factor of 1/2. Therefore, your period is pi. But we do have to pay attention right off the bat. If you didn't factor it, you need to factor out the 2. So we're dividing this by 2. And in my mind, I say multiply by 1/2, pi over 6. So therefore, our phase shift is left pi over 6. And lastly, a midline actually has an equation. It's kind of like an asymptote. It really does have an equation. So y equals -1 is formal there. What did I get wrong? Where?
I see 3/4. You have RB. Want to be negative left, so 3/4.
Oh, yeah. Okay. So I had the negative and then I wrote right. Good catch on that. Left. Okay. And I'm not going to talk all these out at you, but absolute value, 2 pi over pi just simplifies to literally 2. And then this is factored, so grab it, grab that. Right. Before I scroll downwards, what's the max and min value? Well, before I answer that, imagine in your mind, or try to imagine, jeez, everyone's trying to get in front touch of me. Quiet. Sorry. I'm getting old. Like, really, it's bad. Every time something updates, I'm like, what is this update? I used to, as a kid, I was like, yo, this update's sick. It's like everything's cool now. I'm like, why did you move stuff around? Put it back to where it was. Why is it not have to hit that? Like, I really am getting old and cranky. I want you to think about not the vocab words, just what we do when we multiply a function on its outside, when I vertically stretch it by 2. What's going to change here? And what that really means is, like, if you're not sure, plug in some values. What would 2 sine x be? So if you rotated 0, what's the y coordinate if you rotate 0? Still 0. And then times 2, still 0. Get what I'm doing? Like, I'm literally plugging in 0 radians. So 2 times sine of 0 radians. Sine of 0 radians is 0. 2 times 0 is 0. Every time we get a 0, they're going to stay put. And what are zeros? X-intercepts. So these stay anchored. All the x-intercepts stay anchored. But pi over 2 has a maximum value of 1. There it is. Well, this still has a maximum value of 1, except now we're smacking it with a times 2. And if I haven't made my argument, I don't know if I can. Because to me, at that point, it's pretty obvious. Your minimum value of -1 is now a minimum value of -2. So the amplitude plays a role in our max and min. It literally is going to scale up the 1 and scale down, or I guess down the -1 to 2 and -2. But what if I shifted this entire graph? What if I now say, yo, what about 2 sine x plus 3? Well, then I would take this stretch graph and bump it up 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Actually, if I scale this a little more carefully, because this should be like that. Like that. But the idea about transformations is there. I know that's messy, but my brain thinks about it is a little bit messy. With that being said, we're at -1. Are we going up a full 1 unit? I lost you. It's all good. This is probably a bad example to start with because it's got a fraction. Let's go with C. We have a cosine wave, doesn't matter. Cosine by itself, max 1, min -1. Do we agree? Say yes. Good. Better say yes. Because literally 1 is the maximum on the use. Okay. Now you scale that graph by 4. So what's our maximum now? And minimum? -4. So you got those numbers working. You had 4 and -4. That's if you don't shift the graph. But now shift 4 up to what's your max? And what was this before? So if you shift it up to, done. Your max and your min, take what you know, scale it, and shift it. Scale it and shift it. If you want a formula, you take your 1, you multiply it by your amplitude, and then you add your midline. That's what we did, though. Take the 1, which is the maximum, scale it by the amplitude, and then shift it up. Your min, You take the -1, multiply it by your amplitude, and add your midline value. Shift it up. Once you understand it, you won't see it as a formula. You'll see it as a transformation. So the max in this example, 1 times 4 is 4. Shift up 2, 6. Min, -1 times 4 is -4. Up 2, -2. What's the domain of every single sinusoid?
Negative infinity to infinity.
Negative infinity to infinity. Can we input any number here and get an output? Yup, it repeats itself. It's periodic. And we can input any negative number. We can input 0. We can input any number. So for both graphs, the domain will always be all real numbers. What's the range of this particular graph? Right there. -2 to 6. And that's how your maximum value can help your range value there. Okay. I'm watching the clock. The time just moves so fast in here. They say time flies when you're having fun, and it is like flying so fast. Must be having a lot of fun. So here's the main idea. Trying to give it as simple as I can. Trying to teach it like just logically. We're shifting the graph. So you stretch it and shift it. That's going to affect your max min. That's how you can get your domain range. But if you're looking for something a little more concrete, there's a formula for how you find your max min value and therefore how you get your range value. Okay. Does anyone see anything else in my work that might be wrong? That looks good. Okay. So I think we have enough practice with that. We're going to skip tangent for this lesson. I did want to leave now with writing a sinusoid. Write an equation using both sine, so you understand the directions here. This says use sine, and do it again using cosine. Okay. And we want C to be the smallest positive number. A and B have to be positive numbers as well. So basically we're trying to use the smallest positive number here, which means we want to, let's see, if that's a positive number, that's really a shift to the right. So I want to try to do the smallest shift to the right as possible. Write an equation, where C is the smallest positive number. So like 3 is a positive number. And if I sub in 3, that would be 3 units right. But 2 is a positive number. That would be a smaller. All right, so now I see it. I want the smallest shift to the right as possible.
When we normally think of the equation of a sinusoid wave, B is distributed within, but here it has it factored out.
Because it's helpful. Okay. And if we need to distribute it in, it's easier. Yeah. All right. Worry less about those instructions and just get a function on the paper is my main concern. That teacher's being super nitpicky. I like it, but let's just talk one out. If I have to write a sine wave, I'm looking for crest, trough.
I see the max is 3 and the minimum is 3, -3.
Cool. But if I have to write a sine wave, I'll build right off of you in a second. I'm looking for crest followed by trough. And I see one right there. My eyes just gravitate right there. I'm not done, but now I'm going to focus solely right there. Everything else is distracting. The next thing I think about is my midline. So I'm gravitating, my eyes are gravitating the same way we are. We definitely have a max of 3 and a min of -3. What's my midline? 0. Has it been stretched vertically beyond 1? By how much? Try again. The maximum of sine, the parent, is 1, and the minimum is -1. So not 2, but 3. So I already have half of this equation done. Y equals 3 sine plus 0. I started by finding a crest trough. That's a sine wave. It's how my brain functions. But then I just grab the middle because it makes sense to me. And I say, how far up? 3. How far down? 3. That's called your amplitude. And your middle is 0. I have 2 out of the 4 things I need. Now we have to attack the inside stuff. Earlier in this lesson, we said from start, I went too far. This distance on the parent. On the parent, it's 2 pi. Is this 2 pi? No. So there's a b value. I don't have anything fancy here except this. 2 pi. There was something, I don't know what it was, but after it made 4. We can solve that equation. So again, I don't know what it is. It's not immediately obvious to me, but I can do baby algebra. Set up the equation, 2 pi divided by something made 4. What was that something? Multiply by b, divide by 4, simplify your fraction. What do you get?
2.
Try again. Pi over 2. All good. But it literally is pi over 2. David said something very wise. I'm going to put that in its factored form. And from earlier tonight, so I'm trying to make connections to everything that was discussed, which actually started with your discussions. You said a lot of smart things tonight. But right here, our y-intercept. Like if it's on the y-axis, then it hasn't been shifted at all.
Wouldn't it be plus x?
I got you. Yes, it is going to be plus x. But I just want to emphasize there is no phase shift. How did I know that? It's still starting at the y-intercept. All right, so it's still starting right on the y-axis. Because we're going to see in a moment, you can look right over there. That's not going to be the case. All right. So, yes, Roman, but I'm overkilling this. I'm going to fill in all my zeros. And that's a perfectly fine function. Obviously, it's not simplified, but there it is. Now let's just put the polish on it. Let's clean this up. Y equals 3 sine inside. I'll distribute, but I really don't even need to distribute because minus nothing is just a waste of time. So inside we have 3 sine of pi over 2x. And there's the sine function. We'll do cosine before we leave. I know you're so excited to do it, but I want to stick with sine for a moment. Okay. We'll come back to this and do a cosine in a moment. While it's fresh and we have a little brain juice left, because I know our brain juice is probably wearing thin at this point. I'm going to look for a crest followed by a trough. Good? Then I say, let me find the middle. Boom. Once again, 0.
It's 2 sine.
And I went a little quick there. And then there you go. Yes, you're right. And then from there, I say, now start counting out, because that's going to be my amplitude. How much do we stretch from the middle? 2. So we're going to say y, I love doing that, y equals 2 sine, give myself some space, plus 0. No, I don't need to write the plus 0, but I like to for completeness. Make sure I got all 4 parts. I'll clean it up at the end. Now, I want you to think what the period is. Or what is the equation we're going to write? So 2 pi over b, don't say that. No, I don't mean to be rude. I want everyone just to do this independent thinking for 1 minute. So we're all going to start with this, 2 pi over b. But what goes here? Don't say it out loud yet. Is the answer 5? What is the answer?
6.
4 or 6? What do you think? 4?
6.
All right, I think 4 too. I'm on your team. So let's count how many steps it takes to get to the end. We're going to show them it's 4. 1, 2, 3, 4. See, we're at the end. I think they won. 1 step, 2 step, 3 steps, 4 steps, 5 steps, take 6 steps. So you're just gonna how I think about it, get me to 0, that's a step, and 5 more steps gets me to the end. So 6. Can I have some just slightly suggest? How many steps is it from maximum to maximum?
6.
You can also, even though we're focusing on the highlighted orange, it's okay to look at other places if it's helpful. That's a hint for something coming up. I'll leave it at that. Okay? So even though we're using this, notice from max to max, that's also going to be the period. Or from min to min, that's also going to be the period. Cool. All right, anyways, we're going to call this 6. We're going to multiply by b. We're going to divide by 6. We're going to get pi over 3. And we're starting, being silly, but nope, we're not starting on the y-axis. We're starting left 1 unit. How do I shift left 1 unit? Plus 1. And, whoop, okay. Come on, man. Technically, that's it. Clean up only. Y equals 2 sine. Distribute pi over 3. You get pi over 3x. Distribute your pi over 3. You get plus pi over 3. And then the plus 0 fizzles. Why that's considered simpler, I don't know. Because to me, that's simpler. But I don't make the rules. So it is what it is. But I like the top one. Come on. I know there's one. These are all, are you kidding me?
They're all centered around 0.
Yeah. Ah. Find this. Sorry, teacher, friend. I would have structured this a little bit differently. I want to do two more things. I want to do one more sign and then show you the connection. Like cosine's pretty the same thing. It's pretty much the same thing. So I'm going to do this sine one. We'll do a cosine one here, or a different one, and that's it for tonight. And I'll just give you a heads up. There's a couple applications. I didn't think we'd get to them, but I'm always optimistic. So if you're going to start your homework ahead of time, you can try the applications on your own, or we'll definitely start next class with applications, and we're going to look at the graphs of the other trig functions, not in as much detail. So just give me a heads up what next class looks like. And we're really pretty much the majority of the test is at this point kind of working. So homework tonight, if you're going to get started before next class, make your best effort. You should be able to do almost everything that you see there. Let's go. Do you see a crest followed by a trough? So let's run what David notices. I see a trough followed by a crest. We'll play into that in just a minute. That means we need a transformation. We'll play into that in just a minute. What's the minimum? Right there, -1. What's the maximum? 3. What's the middle? I mean, it's labeled for us, but how do you find the middle of 3 and -1 if you didn't have a graph? Average. 3 plus -1 is 2, divided by 2, which is an average, and that's how you get your middle. Right? So if you just had ordered pairs, average your max value with your min value, and that'll give you the middle. So keep that in mind in a minute. I'm going to put it on the tablet in just a second. But from the middle, which is 1, how much do we go up to get to 3? How much do we go down to get to -1? Better be the same thing. So was that a stretch? Heck yeah. And for the first time tonight, I'm literally going to show you from your midline to your max, or from your midline to your mid. That is what amplitude is. It's how far off from the middle you are. Okay. So if you go back, I'm not going to scroll back up, but on the parent function, the midline was 0. Actually, we can talk it out. And the max was 1. You're 1 up or 1 down. That's why there was a 1 in front of it. Okay, anyways. Enough to start writing some stuff. Because we're starting with a trough, we need a reflection. The amplitude was 2. By the way, when you take that absolute value, you still get a 2. Sine, and our midline was 1. How many steps from start to end? What do you say? How many to 0?
2.
How many to the end?
10.
How many total? 12. Cool. So 2 pi over b is 12. Oh, I changed up the colors. That's all good. Doesn't really matter. I was trying to stick consistent. I can't remember what I used anymore. It's fine. But I definitely know I used 2 pi over b is 12. Multiply by b, divide by 12, pi over 6. And then, last but not least, did we start? Nope. We didn't start on the y-axis. It's been shifted. And by the way, you can't say it's been shifted to the right. Why not? Because we didn't start with a crest. That would have been wrong. Do you see what I'm saying? Do you see like how that's wrong? You can say, well, why didn't you go to over here? Isn't that, you could say it's shifted that way? Sure, but then you wouldn't have a reflection. If you're starting with crest followed by trough. There's a lot of similarities. There's an infinite ways to write this, but you have to make a choice. And that's why I like the highlighting. We're starting here. We're starting with a trough. So therefore, it's 2 units to the left. We have x plus 2 on the inside. I hate the word clean it up, but clean it up for textbook's sake, not for what makes sense sake. But you get pi over 6x. I'd get 2 pi on top of 6. That's a pi over 3 plus 1. And I want to end with cosine. How could we write a cosine of this graph? Almost the exact same way.
We'd want to shift it back by 1.
Where's the delete button? You said earlier that sine starts at its middle, and where does cosine start?
Max right now.
So you have a choice to make. Let's start at its min. I claim enough information. I don't even need the full cycle. Again, hint for something that's coming up in the future. I just need enough, and I claim this is enough. I have a minimum value. That's where I'm going to start this graph. Hey, I'm trying to get you guys out right on time, sorry. Because it's starting at a min, cosine's not starting at its max, we have a reflection. We good with that? How much of the rest is going to stay the same? Practically everything. Practically everything. Is the midline still what it was with sine? Do we still have the same amplitude? So that's this. That's this. Do we still have the same period? Yes. I didn't see any change in cycle here. So we still have pi over 6.
We just want to subtract, add 1 to the other number. Add 1 to x.
Everyone agree? Agree? The only other thing that really matters here is where are we starting this minimum value? Is it starting on the y-axis? Nope. It's starting 1 unit to the right. X minus 1. And I'll save the cleanup for you because that's just distribution. You can write a sinusoid for anything. And there's a lot of similarities. I hope you're leaving tonight strengthened from your trigonometry class. You're seeing this under a new set of eyes. That's the strength you need to be in calculus. All right. See you guys on, try to get the day right the first time. Thursday. Okay, cool. See you Thursday.
It's not like 3.5.
Huh?